Assalamualaikum and hi. Today we will start our class on advanced forecasting for title Fuzzy Logic. So what is actually fuzzy logic? Experts usually rely on common sense to solve problems. They also use vague and ambiguous terms. For example, though the power transformer is slightly overloaded, I can keep this load for a while. Let us begin with a trivial but still basic and essential statement. Fuzzy logic is not logic that is fuzzy, but logic that is used to describe fuzziness. Okay, please understand this statement. Fuzzy logic is a theory of fuzzy sets that calibrate vagueness. Fuzzy logic is based on the idea that all things are made of degrees. For example, temperature, height, speed, and distance. The beauty of fuzzy logic is it all come on a sliding scale. For example, the motor is running really hot. Tom is very tall. Electric cars are not very fast. Hobart is quite a short distance from Melbourne. Sydney is a beautiful city. Meaning that actually the really hot scale we can adjust it to be depends on the environment and condition. Fuzzy logic reflects how people think. It attempts to model our sense of worth, our decision making, and our common sense. As a result, it is leading to a new, more human and intelligent system. For example, previously you have learned about Boolean logic. So in Boolean logic, we only have two states. We have true represented by 1, false represented by 0. So we can see here there are absolutely a boundaries between these two results, a very exact boundaries. However, in fuzzy logic, we have multi-value logic. So this multi-value logic is actually scaling from 0 and 1. However, there are gradient from 0 to 1. For true, it can come on 0.8 and false can come in 0.2. So it has a ranging of scaling here to represent true and false. So for another example, in a Boolean logic, we have completely true and completely false. However, in fuzzy logic, we have completely true, partial true, and completely false. So in fuzzy set, we have very fuzzy boundaries in terms of two decisions. So the fuzziness is on this side. And if you have a Cripps value or a Cripps set, you have exactly, if you cross this border, it will be true. If not in this line, it will be false. So what we are looking is at the fuzzy set. So the fuzzy set, if you can see, in terms of fuzzy set and the Cripps value that we have learned previously. So in this Cripps set, we have a really fine line here, which represent the border between decision in terms of this set and the outer set. However, in fuzzy set, we have a very fuzzy area here that can be representing either this is almost in this set or outside the set. So we will look at the example. So if it's cold, is it cold? In Boolean logic, we can say yes, it is cold. No, it is not cold. So if it is in a fuzzy logic, we can represent it in a human type of wording. So it is a very much cold, almost about 0.9, not 1. Okay, 1 is very cold. Okay, and we can say that it is a little cold or a very less cold. So this fuzziness is very, the beauty is here. So another example is, if you can see here that in Boolean logic, we can say that is Nick honest? You can say that yes, he is honest. False, he is not honest. However, in fuzzy logic, you can say that Nick is extremely honest when it is 1. Very honest at 0.85. sometimes honest at 0.35 and extremely dishonest at 0. So that is the beauty of fuzzy logic. So here you can see also the example of between the Boolean logic and the fuzzy logic, giving you a very sharp decision, and for the fuzzy it will have a different scale before it reach the main decision between two boundaries. Okay, for example, that we have the tap water temperature here, we can say that in Boolean we can represent it something like this. If it is in this range 0, it will be cold, and if it's in this range it is hot. Okay, so the Cripps set theory is governed by a logic that use only two types of values. We have true and false. However, in fuzzy theory, we have the element belong to the fuzzy set with a certain degree of membership. So we can see that if it is at 0, it will be extremely cold, and if it is at 1, it will be really hot. So between that, we can have a range of cold, so we have a mild here, and then we have a hot and really hot here. So we can see that there's a certain degree of membership to represent the parameter that we want. Okay, if we have something like this, we have a degree of membership of a tall man. So if we have this list of persons, so we have Chris, Mark, John, Tom, David, Mike, Bob, Stephen, Bill, and Peter. So this is the range of height of for these names. Okay, so what happened? What is the difference between Cripps value and also the fuzzy? Cripps is a Boolean value, so we can see that if it is a Cripps value, okay, you have something that is very sharp here. If somewhere that if Tom is 181 over here, so Tom is considered tall. However, if someone like David is 179 over here, so if you are using Cripps value, we can say that the result will show that David is short. So is really short or not? So this is not really accurate because the difference between David and Tom is not really too big. And there come the beauty of fuzzy set, that we can say that it is slightly it's slightly tall and not short. Okay, something here that can represent that, giving you the fairness of your decision. Okay, here you can see that there are two different temperatures. So if we have the decision, so we have our Boolean logic. If it is in this range, this is warm, and if it's at this range is hot. So if we have a temperature of 26.9, you say that it is warm. If you find it 27.1, then it is hot. So it's not really representing the real data. Okay, so in fuzzy logic, there are overlapping between this membership function here. So we can see that here is 26.9, okay, and 27.1. So here that we can say that 26.9 and 27.1 belong to the same set, approximately in the same degree. It will be somewhere here. It can be represented by hot and warm. Same goes to this example. So we can see that if we are using the Boolean method or Cripps set, it will be exactly that. At 40, it will be below that 40 is slow. After it will be fast. So it's not representing the right amount of decision. However, if you see in membership for fuzzy logic, we have overlapping between membership function here or member set here. So we can see that between 40, it can be say rather slow and slightly fast. So this is special one is at this overlapping area of the decision making. Okay, so see you in the next video.